Hello guys, welcome back to the channel. So after discussing all about basics of coding using Python, data preparation and exploratory data analysis, today we discuss data preparation phase to model the data, right? And we discuss the partition the data and balance the training data set using Python, then build cart decision trees using Python, build C5.0 decision trees using Python, and last is build random forest using Python. So let's start our topic. So first of all, we discuss about data preparation phase to model the data. So the data preparation phase to model the data involves the following key steps. There are 7 steps here. We discuss one by one each step. First is data collection. So gather the data from relevant source. Then second is data cleaning, in which we handle missing values, remove duplicates and correct errors. After data collection and data is data transformation, in which we standardize, normalize, or encode categorical variables if necessary. Then feature engineering, so create new features or modify existing ones to improve model performance. And fifth step is partitioning the data. So split the data set into training and testing sets, usually 80 by 20 and or 70 by 30. Then sixth step is balancing the data. So address class imbalance using techniques like oversampling, smart or undersampling, right? And last step is data exploration, in which we analyze the data for patterns, outliers, and relationships between features. Now we start our topics. First is how to partitioning the data in Python. So partitioning the data into training and testing sets is a fundamental steps in model training. This can be easily achieved using train, test, split from sklearn. Here we import necessary libraries, right? From sklearn.model selection, import train, test, split. Now column we want to predict, first is x assign dataset.drop, target variable x is 1, feature, then second y assign dataset target variable. Then Xtrain split the data into training and testing sets. So first we use Xtrain, then Xtest, Ytrain, then Ytest is assigned train test split XY test size is 0.2. Now random stage is 42. Now we check the shape of the splits. So simply we use train function and Xtrain shape for check the shape of the split and Xtest dot shape, right? Now we get output here. X train shape the number of samples and features in the training set. Then X test shape the number of samples and features in the testing sets. Then Y train shape the number of labels in the training set. Then Y test shape the number of labels in the testing sets. Now, since the data set is split with 80% of the data for training and 20% for testing, the exact numbers for the shapes depend on the size of your data set. Got it? So, for example, if your data set has 1000 samples, so X trend shape is 800 and features 80% of the samples for training, and second X test shape 200 and features 20% of the sample for testing. Now third is Y train shape. So again 800 80% of the labels for training, and last is Y test shape. So 200 20% of the labels for the testing. Now we discuss how to balance the training data set in Python. So to balance the training data set in Python, especially when dealing with class imbalance, you can use several techniques. The two most common approaches are oversampling the minority class and undersampling the majority class, right? So using smart means synthetic minority oversampling technique. So smooth creates synthetic samples for the minority class to balance the data set. Steps, there are two steps in to use Smart. First, install Embellion pipes install imbalance learn. Second is use smart to oversample the minority class. Now, first we import necessary libraries as usual. Then from mblarian learn over sampling import smart from collections import counter. Then apply smart to balance the training dataset here. So smart assign smart random state is 42. Now extend resampled by trains resampled is assigned smart fit resample extend by train. Now we check the class distribution before and after smart. So we use print function original class distribution here and counter by train. Then again we use print function resample class distribution counter by train resample. Now before smart the original class distribution may be imbalanced, but after smart the data set will be balanced with synthetic samples added for the minority class. Got it? So the output we get original class distribution is counter 0 is to 800 and 1 is to 200. And resample class distribution counter is 0 is to 800 and 1 is to 800. I hope you got it the how to balance the training data set in Python. Now we discuss how to build card decision trees using Python. So here we import matplotlib.pyp plot as plat, then erase load erase to load erase dataset, x assign erase data and y erase assign erase target. Now we split the data set from with xtrain, xtest, ytrain, ytest, assign train test, split, and xy test size 0.2 and random state is 42. Now, after split the dataset, we create and train the card classifier. So we use CLF, assign decision tree classifier, criteria, Guinea, and random state 42. Now CLF fit xtrain, ytrain. So evaluate the model. How we evaluate? So y.pred is assigned CLF predict xtest and accuracy is assigned accuracy score ytest and ypred. Now we use print function to print accuracy and we use print function to print classification report. So classification report ytest and ypred target names is arise. Now after evaluate the model we visualize the decision tree. So figure size is 16 and 10 and tree plot tree CLP feature names erase feature names class name is assigned erase target names and filters and PLT show. So the output we get accuracy is 1.0 and classification report as you can see we have in row and data column. So precision column we have recall column we have and F1 score and support. And in row, Setosa, versicolor and Virginica and accuracy, macro average and weighted average, right? So after that, we discuss how to build C5.0 decision tree using Python. So here we import pandas as PD from sklearn model selection import train test split. From sklearn tree import decision tree classifier. From sklearn ensemble import gradient boosting classifier. And then from sklearn matrix import accuracy dot score. Then from sklearn datasets import load arrays. Then we load the arrays dataset. How we load? So data is assigned load arrays. Then x. Then we assign x as pd dot data frame data columns data feature names. Then we assign y to pd dot series data target. Now split the data into training and test sets. How we? So xtrain, xtest, ytrain, ytest is assigned train test split, xytest size is 0.2, random state is 42. Now train a basic card decision tree. So how we train a basic card decision tree? So we use card model and the decision tree classifier random state is 42 here and class card model fit xtrain and ytrain. So x test evaluate accuracy of gradient boosting models, accuracy of GB, accuracy score is ytest and ypred. Now make the predictions on the test set. So here ypred cart is model predict evaluate accuracy of cart model. So accuracy cart accuracy score is ytest and ypred cart here. We use for print to print cart model accuracy here. So train a gradient boosting model and through GB model gradient boosting classifier random state is 42 here, GB model fit, as you can see. So after that implementation of that code, we get output of cart model accuracy is 1.0000 and gradient boosting model accuracy is 1.0000. So after that, we discuss how to build random forest Python. So here we import pandas as PD from sklearn, ensemble import random forest classifier, then from sklearn model selection import trend test split, then from sklearn datasets import load arrays, then from sklearn metrics import accuracy score. Now we load the arrays dataset. How we load? So data is assigned load arrays, then X is assigned as PD dot data frame data, columns, data features, names. Then Y is assigned as pd.series data target. Now split the data into training and testing sets in 80% train and 20% test. So X train, X test and Y train, Y test is assigned train test split where XY test size is 0, random state is 42. Now initialize the random forest model. So how we initialize RF model? Random forest classifier and estimators is 100 and random state is 42. Now train the model. So RF model fit, X train and Y train. Now make predictions on the test set. So we use YPRED and assign the RF model predict X test. Now we evaluate the accuracy of the model. So accuracy we evaluate through accuracy score, Y test and YPRED. Here we use print to show. So after implementation of that code, we get output as a random forest model accuracy is 1.0000 as you can see. So thank you guys for watching this video, and I hope you get idea about data preparation phase to model the data. Thank you.